the equation of a tangent line of f of x at x equals a, we need a point. So our point in this case is going to be a f of a. We just need an x and a y value. Our slope, on the other hand, is our f prime of x. So f prime of a, the value we need. So we can use two different forms to kind of look at this. We have point slope form, which is generally written as y minus our y value, in this case f of a, is equal to our slope, f prime of a, times x minus a. Another way that we could write it is moving that f of a over, so it's y equals f prime of a times x minus a plus f of a. So when we look at these problems, we just need to decide what we need. So we need our point and we need our slope. So in this problem here, a function f of x is continuous and differentiable for all values. We know that what we're looking at is f of 4 is equal to 7 and f prime of 4 is equal to 2. So we want to write our equation at x equals 4. So our point, f of 4 equals 7. We have an x value of 4, a y value of 7. And our slope is our derivative, so f prime of 4 equals 2. So our slope is 2, which gives us y minus 7 is equal to 2 times x minus 4. The function h of x is differentiable for all values of x, with selected values of h and h prime in the table above. So write the equation of the line tangent to x equals 1. So the main thing here is just knowing how to use the table. So we need a point, and we need the slope. So our point at 1, when we're looking here, 1 and h of x gives us negative 5, so 1 comma negative 5. Our slope is our derivative, so still at 1, but our h prime of x, so negative 4. So we get our equation of y minus negative 5, so plus 5, equals negative 4 times x minus 1. Okay, so the big thing here is more of just that equation of a tangent line more than anything else. When we get to the next step, we're going to remind ourselves of some things, like what we do when we don't have something like this one. So let k of x equal x squared plus 5x minus 3. Write the equation of the tangent line at x equals 3. So we have some things that we need to do. The easiest way to do this is finding the point. So plugging in k of 3. Three squared is 9. 5 times 3 is 15. Which gives us 21. So I can go ahead and start writing my equation. Y minus 21 is equal to blank times x minus 3. When we do our equation, in this particular case, it's going to be a lot easier to find the derivative of what we would normally do, but because we haven't re-talked about power rule, this is the way that I would do it if I didn't know power rule for some reason. So k prime of 3 is going to equal the limit as x approaches 3 of our function x squared plus 5x minus 3 minus our k of 3, which is 21, divided by x minus 3. So this is one of our derivatives at a point. And then we're just going to use what we know about limits. So the limit as x approaches 3 of x squared plus 5x minus 24. So I'm just simplifying it down. So now what we're going to do is factor it to try to get a common factor with x minus 3. Thankfully, x squared plus 5x minus 24 is x minus 3 times x plus 8. And I know that because 8 times negative 3 is negative 24, and 8 minus 3 is 5. When I do that, I'm now looking at the limit as x approaches 3 of x plus 8. And now I can kind of use direct substitution here. So 3 plus 8 gives us 11. So I can go ahead and put 11 in. Thankfully, we are not going to be worrying about that. So in a second, we're going to talk about what we care about with the